Welcome, fellow learners, to learn about titration. Today, we'll dive into this fascinating world to explore this technique in detail. Titration is a technique used in chemistry to find the concentration of an unknown solution by gradually adding a solution of known concentration until the reaction reaches the equivalence point. Everything's confusing? Well, it will be crystal clear when we'll be done with the titration. At first, let's see the setup. The burette holds a titrant, a solution of known concentration, and the conical flask contains the analyte, along with an indicator. We'll know what an indicator is later in the video. In today's example, hydrochloric acid is our titrant, and chalk solution is the analyte. Now, without further ado, let's get buckled up for the titration. Firstly, the analyte, as in the chalk solution, is added to the flask, along with a few drops of phenolphthalein. Phenolphthalein is the pink indicator, which made the chalk solution pink. In titration, we use an indicator to visually signal the equivalence point, which we will be seeing as we do the titration. Here, phenolphthalein is used as it sharply and sensitively indicates the color change. The titrant or hydrochloric acid is added to the burette. Now the titrant is slowly added from the burette, while the flask is swirled to ensure the mixing of chemicals. A white tile is placed below for better color visibility. As drops pour, the solution slightly gets colorless but soon returns to its pink color. When the entire solution permanently turns colorless, it means titration is completed and the swirling is stopped. Neutralization is indicated, which means the pH of the solution becomes 7, which is neutral. Titration occurs due to the chemical reaction between calcium carbonate, the primary component of chalk, and hydrochloric acid. The acid provides H+ ions, which react with the carbonate ions in chalk. This reaction produces calcium chloride, water, and carbon dioxide, which you can observe as bubbles. The process continues until all the chalk has reacted, signifying the equivalence point. This is why titration allows us to measure the amount of chalk present accurately. Once we know the volume of titrant used, we calculate the concentration of the analyte using the formula. N1 times V1 equals N2 times V2. Here, N1 represents the molarity of the titrant, V1 represents volume of the titrant, N2 stands for molarity of the analyte, and V2 stands for the volume of the analyte. The link for a detailed version of calculations is in the description box below. To recap, titration helps us determine the concentration of an unknown solution through neutralization. With the right setup, careful observation, and calculations, it's a powerful tool in chemistry. Thank you for exploring titration with us today. Ready to experiment? Let's get started in the lab.